Right. Okay. So this is the second session of organic reaction practice, organic therapy. So in the last session, I gave you a small homework. In the last session, we discussed carbon increase in reaction number one, uh, aldehyde ketone reaction with Greenart region, and then we discuss special conversion reaction number one and special conversion reaction number two. Okay. So using them, I gave you simple conversion. So this conversion, you have to do this one using maximum 4 steps. I gave you this one as not more than 4 steps, right? So let's see how we can do this conversion, right? Did you do this conversion? Did you try this one? Okay, 4 steps, right? First of all, since this is an aldehyde, I'm going to add Greenart region CH3 MgBr. Secondly, H3O plus. Then it's forming alcohol. What is the alcohol? CH3, COH, H here, and CH3. We have only learned 3 reactions up to now. Using these 3 reactions only, we have to do this conversion. Later, we are going to do these conversions in different ways, in different parts, by reducing the number of steps. Okay. Now, when you consider this one, we can use here PCl5 to convert this one into alkyl halide in this way. CH3, CCl, CH3, and H here, right? And by adding magnesium diether, I can make Greenart region. CH3, CmgCl, and H here, right? And from here to here, directly we can go for that step by adding the simplest aldehyde, methanol, HC double bond OH. And secondly, we can add here H3O plus. Okay. So therefore, we can do this conversion in this, right? That's very simple. This is what I gave you as a homework in the last session. Not difficult. Right. And the second one, second conversion I gave you is this one. Look at this. Bromobenzene, and it's going for CH2 MgCl. So this compound, right? So this is the conversion, the second conversion I gave you. So for this one also, I told you not more than 4 steps. not more than 4 steps. How we can do this conversion, right? That's very easy. Since they have given bromobenzene, we can easily make the Grignard region by adding magnesium, right? By adding magnesium dry ether, here we can make the Grignard, MgBr, right? And what we can do next? At next, we can do like this. I'm going to add here the simplest aldehyde, methanol, because you can see that in the final product, only one carbon atom is remaining. So therefore, we can add here methanol, and secondly, H3O plus is added. Then the region formed here is CH2OH. Okay, understood? And here we can add PCl5. Then it's converting into alkyl halide, CH2Cl, and magnesium dry. So we have started this conversion using magnesium dry ether, and we have ended up this conversion using magnesium dry. Interesting. So these two are the conversions I gave you as a homework related to the 3 reactions we learned in the last session. Okay. That's very easy. Okay. So today we are going to learn the next reaction. First of all, carbon increasing reaction, number 2. But before that, let's move for a simple exercise again to recall what we learned in the last session quickly. Okay. Let's do a small exercise to recall what we learned in the last session. Exercise number 1. So to do these conversions quickly. CH3OH, that means methanol, converted to CH3Cl, Grignard region. So put on the compound region that we have to add to convert these things. Okay. On the arrow, you can write on the compound. And here we have formed alcohol, secondary alcohol. And then alkyl halide again. Another Grignard region. Right. Okay. This is the first one. Okay. And second one, quickly write down the regions we have to add on the arrow. We are starting from chlorobenzene. Grignard region is formed. And you can see here the secondary alcohol. And then PCl5 is You know that. At next, we have kind of a compound like this, CH. Right. Shall we do this one quickly? Very easy. Okay. Everything we learn. OH to Cl, what is the region we can add? PCl5 or else PCl3. And then we can add here magnesium diether. At next, we can go to here. You can see that green out region. We have started from green out region and we have ended up with an alcohol. So therefore, we can add here, first of all, aldehyde CH3C double bond OH. Secondly, we can add here H3O+. PCl5 here, magnesium diether. And here, what is the region they have added? The new region that they have added, of course, that is methanol. You can understand that one carbon atom has increased and secondly H3O+. And this is very easy. We have added PCl. That's very easy. If you go for the second one, chlorobenzene have added magnesium diether and it has been converted to an alcohol. So first of all, CH3, CH2, C double bond OH. Secondly, H3O+. PCl5, magnesium diether, and CH3, C double bond OH, first of all, and secondly, H3O+. This 1, 2 is very important, right? You have to mention it properly. And PCl5 is added in order to convert OH into C. So this is the second simple conversion. Quickly finish it. Okay, now okay, ne? Right. So this is the third one. In the third one, actually, what you have to do? You have to go for the reverse thinking, right? In the examination, reverse thinking also important. You have to find out the initial compound that they have used and some of the intermediates you have to find. Regions that they have added is given. So using the final one, go for the backward. Go for the reverse. Okay. Quickly do it. Third one. That's very easy. And I'll put the fourth one also. Look at the fourth one. So fourth one also likewise. Initial compound is not given. The final one is given. You have to find it. Okay. Let's see. We have added magnesium ether, dry ether for the first one, and then acetone, CH3, C double bond, CH3 is added. Acetone. And next, diluted sulfuric. Remember, students, if H3O plus is not given in the examination paper, right? Sometimes they might give water. Sometimes they might give diluted acid. Okay. So therefore, instead of H3O plus, we can use diluted sulfuric, doesn't matter, right? In case if they haven't given H3O plus. Remember those things, very important. And then PCl5 is added to here. At next, magnesium ether again. Then they have added methanol. Right, in this way. Finally, they have added H3O plus. Final product is CH3. Two methyl groups are connected to the carbon. Benzene is connected there. And CH2OH. Right. So the final is given. You have to predict the previous compounds. Okay. Right. Let me go for the third one. Okay. Since we are going backward, we have to start from here. Let's see. Very easy. So we have formed an alcohol and they have added here an aldehyde. What is the aldehyde? Since there are two carbon atoms, this is ethanol. So from the ethanol, CH3 group came here. Hydrogen is came here. Then the remaining ones are what? Related to the green earth region, right? This C double bond carbonyl group converted to COH. So this group CH3, yeah, this one should be CH3, CH2, CH2. Now that group is came from where? The green earth region. So therefore we can put here CH3, CH2, CH2, MgCl. Why? Here they have added chlorine. Then, so after the magnesium dry ether, that alkyl halide is reacting with magnesium to form green earth region. You have to think revise, right? So we are adding PCl5 for whom actually? To convert this one into chlorine. We are adding PCl5 for an alcohol. CH3, CH2OH. Right? This alcohol name is propanol because there are three carbon atoms. Now again, H3O plus is added and look at the previous steps also. Methanol is added. Then definitely, this is actually the formation of alcohol using green earth. So therefore, let think about in this way. OMGBr. CH2 OMGBr, H here, H here. Right. So this is the methanol compound. This methanol compound is in here. Two hydrogens with carbon atom. And then the remaining one is Grignard region. CH3, CH2, MgCl. Let me put here Cl, okay? And then Grignard region is formed by adding magnesium triether for what? Alkyl halide. So therefore CH3, CH2, Cl. And PCl5 is added and form alkyl halide. Started from alcohol, CH3, CH2, OH. Ethanol. We have started from ethanol. Ethanol, PCl5 added, therefore alkyl halide. Grignard region, aldehyde is added, therefore the intermediate of what? With the Grignard region, MgCl is connected and H2 plus is added, then again alcohols are formed. So you can see that in these conversions, the number of carbon atoms are increasing, isn't it? We have started from a small compound. Ethanol is actually what? Small compound which is containing only 2 carbon atoms. But look at the final one. In the final one, there are 5 carbon atoms. Right? So this Grignard region reaction is very important to increase the number of carbon atoms. That's why we discuss carbon increase in reactions separately. Addition to them, we have to learn these kind of special conversion reactions, addition of magnesium triether, addition of PCl5, likewise. These are special conversion reactions. So this is the third one. Okay. Shall we move for the fourth one? Go reverse. So when you go for the reverse here, CH3, CH2Cl, CH3 here, and this is the benzene ring. Now this is actually CH2 OMgCl, right? OMgCl. You have to go for the reverse. Now we have added methanol. So the methanol is formed. Methanol is added. So therefore, the previous region is this. Try to understand, because this CH2O group came from this aldehyde. Okay. Previously, we had alkyl halide. That's how Grignard region is formed. Grignard region is always formed by adding magnesium triether for the alkyl halide. PCl5 added means definitely the previous one should be alcohol. And here H3O plus, this is like H3O plus, right? Therefore, the previous one should be definitely OMG, Cl something. They have added acetone here. You can clearly see that these two CH3 groups came from the acetone compound they have added. So then what is the remaining one? Remaining one is benzene MgCl. After adding magnesium triether, it has formed Grignard region. Then the previous compound is chlorobenzene. Actually, we have started from chlorobenzene, but look at the final product we got. Chain of reactions, right? Chain of reactions. You have to practice these things. Okay. Without practicing these reactions, suddenly you won't be able to do the conversions. First of all, practice these things. This is the third one and the fourth one. Right, okay. Shall we go for the next topic? Next topic is actually carbon increase in reactions. Quickly finish these conversions. Right, okay. So let's move for the next topic. Carbon increase in reactions, number 2. Put down the heading, carbon increase in reactions, number 2. Number 2. What is it? Carbon increase in reaction number 2. Reaction of alkyl halide with potassium cyanide, KCl. Okay, potassium cyanide is KCl. That's very easy. Look at this. Just imagine we have alkyl halide, RCl. RCl, alkyl halide. For this alkyl halide, we are adding KCl, potassium cyanide. So what do you think? What should be the result? So the result is RCl. That chlorine is replaced by cyanide group. Okay. So this is alkyl halide. This is alkyl cyanide. Okay. Right. So this is the reaction. Now we are including one more reaction for the conversions. We have started from alkyl halide and now we have alkyl cyanide. That's all. This is the reaction. In order to convert Cl bromine into CN cyanide, what we have to add? Potassium cyanide. Potassium cyanide. Right. Write down these examples. Few examples for this one. Example number 1. CH3, CH2, Cl adding KCl converts into cyanide. Okay. So what should be the byproduct as you think? Potassium is connecting with the chloride eliminated. So the byproduct is KCl. It's not important. But you can predict the byproduct also. Got it? Second one, CH3, CCH3, H bromine, and we are adding KCl. What will happen? Instead of bromine, cyanide group will add there. And KBr is the right. Third one, chlorobenzene. Can we have that kind of a reaction? No, there is no reaction. We have discussed about this one previously. Can you remember for phenol, when we had PCl5, no reaction? This one, under the special conversion reactions, we learned that by adding BCl5, we cannot form chlorobenzene. There is no reaction like this because of the resonance stability of this compound. Likewise, here also chlorine can give the electrons to the benzene ring. That means here carbon atom is there. That carbon atom is forming a double bond with. It is known as a partial double bond, not completely double bond, a partial double bond with chlorine. So therefore, that bond is not easily breakable. That bond is what strong, so it's forming partial double bond. Therefore, chlorine atom cannot eliminate from the compound. So therefore, no reaction after adding KCl. So no reaction by adding KCl for the chlorobenzene. Okay, keep that in your mind. Quickly write down these reactions. Fourth one, what about this one? Benzene CH2Cl. That's okay, that's fine. Because chlorine is not directly connected to the benzene ring, right? It's okay, it's fine. Therefore, CH2Cl. Next example, number 5. We are adding KCl here. CH3CH2. Okay. And the next example is also so important because of the compound. Look at this compound, will you? Number 6. Right. Remember, students, this kind of a compound is known as vinyl halide because carbon chlorine bond is there, but that carbon atom is connected to a double bond. So this is also what forming some resonance structures. So resonance stability. This double bond can be shifted between carbon and chlorine again because of the resonance stability. So therefore, the chlorine cannot be easily removed from the compound by adding KCl. So therefore, no reaction after adding KCl. For vinyl chloride, there are no reactions. Okay, try to understand. If you see carbon chlorine bond and that carbon atom is connected to a double bond or triple bond, there is no reaction with KCl. Na? Try to understand. So you have to remember these kind of exceptions when we discuss about the reactions. These exceptions are also very important. Quickly. Now let's discuss few examples related to this thing. Okay, shall we move for the exercise? After learning each and every reaction, I'm going to discuss some exercises with you. Okay, that is how we build ourselves to do the conversions, to remember the chemical, these organic reactions. Okay, maybe this method is actually suitable for many students. For some students, this method is not suitable. So therefore, so check whether this method is suit for you. If it is not, just leave. Right? Forget about these things. But I'm pretty sure that for many students, this method is okay because we are easily forgetting these things. So little by little, we can recall everything and discuss these things again and again. That will be very helpful to remember these things permanently. Okay, right. Exercise. Right. Start from the methanol converting to methyl chloride. Pre-NAT region CH3 MgCl. You know what you have to add? Put them on the arrows. CH3 CH2 MgCl. CH3 CH2 OH. CH3 CH2Cl. Ethyl chloride. And just now we discussed about this reaction. Ethyl cyanide. And you know what is the region you have to add, right? Just now we learned. Right. So this is the first one. Second question. Bromobenzene. Benzene magnesium bromide. And we have added a ketone, then you will have this compound. So you have to find it. Okay, what is the compound that we have added? And this is converted to OH. CH3 CH3. Of course, after OH, we know that now you're a bit familiar with these things, right? You can predict the next step also. Now after Cl, just now we learned that how to convert Cl into CN, cyanide. That's all. I want you to understand the flow. Okay, so that's what actually they are expecting in the organic conversions also. You don't have to practice many organic conversions. Okay, what you have to do is you have to remember everything together at once. You have to remember everything. That means when you're doing conversions, which compound we have to use, which region we have to use, what is the next step, everything should come into your mind. So in order to do that one, just imagine how much you should practice. Okay. Your memory power is also matter, but a practice will make you perfect at these conversions. So, right, okay. Now, first one, easy. PCl5 is added. magnesium dry ether, then methanol, H3O plus, PCl5, KCl. Easy, very easy. Second one, magnesium dry ether. So look at this one, MgBr came from here, benzene ring came from here. So the remaining things are CH3, C double bond O CH, acetone, or else we can say propanol, to propanol. And OMGBr, if you want to convert that one into OH, we have to add H2 plus. Of course, here we have to add PCl5 and KCl. See how easy these things are? Not difficult, right? Quickly finish these two. Let's move for the next one. Third one. Third one, you have to go for the reverse. CH3 MgBr is added. Okay. And then H3O plus. PCl3. Then again, magnesium dry ether. Next one, methanol and H3O plus. PCl3. KCN. After adding KCN, the final product is CH3, CH3, CH2Cl. Okay. So think reverse. Okay, very easy. Fourth one. Fourth one. CH3 CH2OH alcohol, ethanol. We are starting from ethanol. Added PCl5. Then we are forming Grignard region. What is it? And CH3 C double bond OH. H3O plus is added. PCl5. And KCN is added. Okay. Do the third one and the fourth one. Quickly do the third one and the fourth one. Let's move for the third one. Reverse. Potassium cyanide KCN is added. That means previously we had alkyl halide CH3, CH2Cl. And before that, of course, we had alcohol. CH2OH. And here we have Grignard region, CH3, Mg, MgCl, right? That's how this CH2OH group is framed, because we have added here methanol. One carbon atom has increased. So therefore, methanol is formed. Methanol is added. So therefore, one carbon atom is added. CH2OH is. And before we have this Grignard region, we had alkyl halide. That is tertiary alkyl halide. And before alkyl halide, we had alcohol, because PCl3 adding means definitely we have added that one to alcohol, OH. Right? Then here H3O plus is added. Therefore, the previous compound is CH3, CCH3, OMGPr. And here we have acetone, if not 2-propanone, the ketone. The initial compound is a ketone. Fourth one, PCl5 is added for the ethanol. OH is converting to Cl. Magnesium diether is added, therefore CH3, CH2, Mg, Cl. And aldehyde is added, CH3, CH2, OH, and H here CH3. Sorry, OMgCl. After adding H3O plus only, that will convert into a perfect alcohol. OH, H, CH3. And PCl5 is added to that alcohol. OH is converting to Cl. When we add KCN, what will happen? Cl is converting to Cn. Very easy. In this way. So that is the third one and the fourth one. Right, okay. Now let's move for a small conversion. Let's move for a small conversion. Try to do this conversion. Number 5. We are starting from ethanol. And you have to form a cyanide compound. Just 3 steps are enough. Okay. Just 3 steps are enough to do this conversion. Try this one quickly now. Within 3 steps, 1, 2, 3, done. Conversion is done. Do that one. I'll put the next one also. Number 6. Okay, this one we are starting from chlorobenzene and we have to form this is kind of a cyanide group. Okay, not more than 7 steps. So the 6th one is not more than 7 steps. Do that conversion. 5th one is very easy, just 3 steps. Check that you can do the conversion. Right. Let's see how we can do the fifth one. We have started from aldehyde, ethanol. It's very easy. Here I'm going to add first of all CH3, MgBr. Secondly, H3O plus. Right. Then it's forming CH3, secondary alcohol. And for this, PCl5 is added. Therefore, CH3, CH, CH3, and Cl. And for this one, KCN is added. So therefore, just 3 steps are enough to do this conversion. Okay. What about the sixth one? The sixth one can be done in this way. Magnesium diether is added. Grignard region MgCl. And therefore, after that, methanol is added, H3O plus. CH2OH. Again, I'm adding PCl5, forming CH2Cl. Again, forming a Grignard region by adding magnesium. CH2 MgCl. For this one, I'm adding first of all methanol. So we repeated the same thing, right? It's okay, fine, because we have here 7 steps, not more than 7, but we can maximum use 7 steps. Now, CH2, CH2OH. And then PCl5. CH2, CH2, Cl. From here to here, KC. How many steps we have used? 1, 2, 3, 4, 5, 6, 7. Okay. We have used 7 steps. They have given not more than 7 steps. We have used 7 steps. Therefore, so these are the 2 conversions. Try to understand the flow, how we have increased the number of carbon atoms, to which positions, what are the regions we have added. Now you should be familiar with these things, right? After doing these things, now you can practice past paper questions also, little by little, not all, right? We have just discussed here 3 or 4 reactions. So by using them, actually, we can't do all the conversions, but you can try, okay? Now, in the recent past papers, they have given single step conversions also, right? In the structured essay paper, the 4th question is organic chemistry. So the first part is isomers. Second part of that question is mostly they are giving single step conversions, right? That means, for example, we have alcohol and adding PCl5. What is the product? Very easy. But there are so many reactions, we don't know which reactions are given. So therefore, we need to learn everything properly. Okay. These are the 2 conversions under that. Right. Now we can move for the next one. Special conversion reaction number 3. Quickly complete this one before I move for that one. Let's move for the next reaction quickly. Special conversion reaction number 3. Hydration of alkynes. Let's see. So now we are going to include another reaction for the reaction list. Understood? So special conversion reaction number 3, hydration of alkynes. Right. So what does mean by hydration of alkynes, first of all? Hydration. If not, we can say that addition of water, right? Hydration means addition of water. So when we adding water to alkynes, let's see what will happen. Look at the reactions value. Let me take a simple alkyne in this way. So this is the alkyne we can take. The reagents we are adding here is mercuric cation Hg2 plus in the presence of diluted sulfuric. Some says this one as mercuric and H plus H2O. That is also correct. Both are okay, right? If not, we can use diluted sulfuric as well. So what will happen is hydration of alkyne means, so the water molecules are adding there. Water is there. Hydration means definitely water is there. So water molecule is connecting to this alkyne in this way. Oxygen atom of the water molecule is connecting to one of the carbon atoms, and remaining 2 hydrogens are connecting to the other carbon atom in this way by breaking this triple bond. And here in water molecule also bond. As you can see here, the product is, you can see the product in this way, HC double bond oxygen, and here CH3. That means 2 hydrogens are connecting there in this way. That means we can write down this compound as CH3 C double bond OH. Okay, so you can see that alkyne has been converted into what? Aldehyde here, right? Alkyne has been converted into an aldehyde by the hydration of alkynes reaction. Okay, so what are the reagents we have added? Mercuric cation Hg2 plus cation and diluted sulfuric. Diluted sulfuric means H plus H2O, also correct. H3O plus. Can you understand? Right? So this is the example reaction. Now let's move for the second one. Directly I'm discussing examples here because this is very important. Look at this one. Let me take here CH3 C triple bond. So this is the first example. This is the second example. So this is also alkyne, but what is the difference between the previous alkyne and this alkyne? What is the difference? So the difference is the previous one is a symmetrical alkyne. That means both the ends are equal, right? Both the sides are equal. If you consider the triple bond, the left-hand side of the triple bond is equal, right-hand side also equal. But in this compound, left-hand side and right-hand side both are not equal. This is asymmetric alkyne. This is not symmetric alkyne, right? Here we have methyl group and here we have pyrazine. So when water molecule is connecting to this alkyne, you have to remember to where actually this water molecule is connecting. That means where oxygen is connecting and where 2 hydrogens are connecting. Hydrogen is connecting to which carbon atom and oxygen is connecting to which carbon atom. So for that one, students, remember we have a rule, right? What is that rule? That rule is known as Markovnikov's rule. Okay, Markovnikov rules. This is very important. Markovnikov rule. Markovnikov rule says that rich one is becoming more richer, poor one is becoming more poor. What is it? Rich one is becoming more richer, and poor one is becoming more poor than before. Rich one is becoming more richer, rich than before. Right? So rich with what actually? Rich with hydrogen. That means if you consider these two triple bond carbon atoms, let me name them as 1 and 2 carbon atoms, 1 and 2 here, right? The second carbon atom is rich with hydrogens because hydrogen is directly connected to that carbon atom. But this carbon atom doesn't contain any hydrogen. So therefore, there are three hydrogens. Remember, these three hydrogen atoms are connected to the terminal carbon atom. That means for this carbon atom. So these hydrogens are not belong to the first carbon atom. Right? So among these two carbon atoms, who is rich with hydrogen? Of course, the second one. Of course, yes, the second one is the carbon atom rich with hydrogens. So therefore, when water molecule is connecting, I told you that rich one is becoming more richer. That means hydrogens are connecting to the carbon atom, which is already rich with hydrogen. Okay, what is it? Markovnikov says that when hydrogens are connecting to the carbon atom, hydrogens are connecting to the carbon atom, which is already rich with hydrogen. That means two hydrogens are connecting to the second carbon atom and oxygen is connected to this first carbon atom in this way. And these bonds are breaking, right? Then we can write down the product here. We know that the reactants, the reagents we are adding is mercuric cation, H plus H2O, if not diluted sulfuric. So CH3, C double bond O, CH3. Here we have ketone. That means aldehyde is also possible. Alkyne to ketone. Understood? That is the thing you have to understand here. That is the thing you have to understand. Okay. Markovnikov's rule says that rich one is becoming more richer. And I told you that poor one is becoming more poor. What does mean by that one? That means when hydrogen is eliminating, hydrogens are eliminating with the from the carbon atom, which has least number of hydrogens. Understood? Just imagine hydrogen is eliminated. Here we can't take this example. For instance, if I just say that this one is actually poor with hydrogens, right? No hydrogens. So therefore, hydrogens are eliminating from that one, right? Just imagine here there are two hydrogens and here one hydrogen. And then hydrogen is eliminating from the carbon atom, which is connected to the least number of hydrogens. That's what known by Markovnikov. Okay. It can be considered as the what? It's not exactly Markovnikov, a way of Markovnikov, right? Markovnikov exactly saying that the addition, not the elimination. Right? Try to understand. Let's go for the third example. Let's move for the third example. Third example, let me take CH3, C triple bond, CH3. We are adding here mercuric cation, H plus H2. So here no issue. Why? So this is a symmetrical compound. Since it is a symmetrical compound, no issue. Whatever the carbon atom, you can connect arbitrary oxygen and hydrogens as you wish. Okay, so therefore, we can have the product 2-butanol. That is also a ketone. Let's move for the fourth one. Look at the fourth one. Fourth one is not symmetric. So the compound is CH3, CH2, C triple bond, CH. We are adding here mercuric cation and diluted sulfuric. We are adding mercuric cation and diluted sulfuric. Okay. Then what will happen here? That's going to happen. You can see that, as I mentioned you, according to the Markovnikov rule, who is the carbon atom rich with hydrogen? Left hand side one or right hand side? Right hand side one, because there is a one hydrogen is connected. Hydrogens are connecting to this carbon atom, and oxygen is connecting to the other carbon atom by breaking the bonds. Okay. Then the product is CH3, CH2, C double bond O, CH3, 2-butanol. Okay, very easy. These things are not difficult. And look at this one, number 5. CH3, CH2, CH3, mercuric cation, H plus H2. Here, how we can get the answer? Here, you can get the answer by considering the neighboring carbon atoms. Now, when you consider these triple bond carbon atoms, actually they are not rich with hydrogen. No one is actually connected to hydrogen atoms, right? This one, either this one, no, the other one. Then go for the neighboring carbon atoms. For left hand side one, this, and the right hand side is this one. So who is the rich with hydrogen? This one. Therefore, we can connect hydrogens here and oxygens here. So therefore, look at the neighboring carbon atoms. Who is rich with neighboring carbon atoms will have the highest number of hydrogens. Therefore, hydrogen is connecting. So the compound CH3, CH2, C double bond O, CH2, CH2. So we can get this kind of a compound. Okay. Number 6. Let's try to go for the reverse. Let's try to go for the reverse. Number 6. Let me take here the final compound is CH3, C double bond O, CH2, CH3. Okay. So we can consider that this ketone is formed by oxygen is connected to this carbon atom, and let me choose the other carbon atom as this one. So remove hydrogens and oxygen, then the alkyne is triple bond, and here CH2. Easy. Seventh one. C double bond and CH2. Diluted sulfate. Okay. Now, students, you have to understand that definitely this is the oxygen atom connected to the carbon. Therefore, triple bond should be connected to this carbon atom. So we have to choose what is the other carbon atom. What is the other carbon atom which is containing triple bond? If you consider this one, we have to remove two hydrogens from there. But you can see that only one hydrogen is connected there. So this is not the carbon atom which had a triple bond. It is not. Then this is the carbon atom actually. There was a triple bond, because easily we can remove two hydrogens here, but here actually there are only one hydrogens, right? So remove two hydrogens here, and the remaining one should be CH3. Triple bond CH. So you have to completely think about the reverse. That's so easy. Seventh one. What about the next one? Eighth one. Look at the eighth one. Right. A phenyl group is connected to the ketone. So definitely this is one of the carbon atoms connected to the triple bond. And we can see here, this is the benzene ring, right? So benzene ring carbon atom doesn't have two hydrogens. So therefore this is the carbon atom. Then we can write down the compound in this way. Okay. Eighth one. Easy. Ninth one. We can see that oxygen is connected to this one. definitely the triple bond should be connected to the carbon atom. And the other carbon atom, is it left hand side one or right hand side? If you consider the right hand side one, there are no hydrogens connected to that one. So therefore, definitely you have to consider the left hand side one. So the reactant is hydrogen triple bond C. Okay. So this is all about the addition of water for alkynes, hydration of alkynes gives us ketones, right? And one aldehyde, we discussed that example as the first one. Okay. Now, for our reaction list, a new reaction is added. Remember this one also. Mercuric cation is actually acting as a catalyst. For this reaction, it is acting as a catalyst. Right. Okay. Now let's do simple exercises. Uh, uh, a very simple exercise related to this reaction also, right? That means we have learned five reactions so far, I think, right? Three special conversion reactions and two carbon increase reactions. I'm including all these things under the exercise, right? And this is also now newly added. You have to do everything properly. You have to remember everything properly. Okay, now let's move for the exercise. It's time to do another exercise. Right. One. Alkyne, ethanol, right? Put the reagents on there. CH3, Read out region. That is the first one. Okay. Quickly do the first one. Finish it. Easier. Very easy. And the second one also, we are starting from an alkyne. Here we have a ketone. OMGPR. In this way. Second one. Okay. Quickly do it. First one. Just now we learned the reaction. Mercuric cation, diluted sulfuric is added. And here CH3, MgCl is added. H3O plus is added. PCl5, magnesium diether. And here, first of all, we have added, try to understand the compound that we have added, okay? So this group is came from the Grignard region. And the remaining one is aldehyde, H, C double bond O H. Secondly, H3O plus is added. Okay, everything is easy. We have learned. Second one, mercuric, diluted sulfuric. Let me write down here H plus slash H2. That is also possible. And we have had magnesium, benzene magnesium bromide, the Grignard region, and H3O plus, then PCl5, KCl, right? Quickly finish this up. Right, okay. Let's move for the third one. So third one is a reverse reaction. You have to think reverse. Number 3. Renal region is added CH3, CH2, MgCl. So the final compound is a cyanide compound, okay? Yes. And the fourth one, yeah, that is also reverse. First of all, we are adding mercuric cation, H plus H2. Then green out region is added in the presence of H3O plus, number 1 and number 2. Then PCl3 is added. Magnesium diether. Then methanol, the simplest aldehyde is added. Next, H3O plus, hydrolysis reaction. PCl5 is added. Then KCN is added. After KCN is added, CH2C. Okay, quickly complete this one. Third one and the fourth one, quickly. Right. Let's move to the third one. Reverse. CH3, CH2. Alkyl halide. And CH3, CH2, OH, and here CH3. Okay. H3O plus is added means definitely we have started from OMGPR. OMGCl, sorry. Then we can see that greener region is CH3, CH2, MgCl, MgCl. Then the remaining one is aldehyde, ethanol. Ethanol is formed by adding dilute sulfuric mercury cation. Just now we learned that hydration of alkyne. So therefore, what will happen? Here, hydrogen, carbon, carbon triple bond. This is connecting there. Okay. Fourth one. That is also reverse. KCN is added. Definitely the previous one should be alkyl halide. It can be confirmed because the previous one is PCl5. CH3, CH2Cl, and two methyl groups are here. And this is formed by CH2OH. These two are CH3 groups. Okay. Here we have a benzene ring, CH2OMGB. OMGCl. Two alkyl groups are there. And the previous one, of course, a Grignard region, MgCl, CH3, CH2. Magnesium dry ether is added. This one should be definitely an alcohol. Here, this is an ketone. So the previous one is alkyne. In this way. Okay. That is the fourth one. Right. So let's do a conversion. As number 5, I'll give you a conversion. Quickly do it. Number 5. Right. So this is the conversion. The number of steps are 1, 2, 3. I'll give you, yes, 4 steps are enough. Not more than 4 steps. Quickly try this one. Not more than 4 steps. How we can do this conversion? This is not more than 4 steps. They have clearly mentioned. Right, look at this one. First of all, since it is an alkyne, we can add here diluted sulfuric and mercuric cation. Then it's forming CH3, C double bond CH2, CH3. Right? And then, what about if I add here Grignard region CH3, CH2, MgBr? Look at this decision. Why did I make this decision? Because you can see that in the final product, there are 2 alkyl groups, 2 ethyl groups, CH2, CH3, CH2, CH3, 2 ethyl groups. Already we have ethyl group. So if you want another ethyl group, we can put its Grignard region in the presence of H3O plus. And then CH3, OH, CH2, CH3, CH2, CH3. We can add here PCl5. And KCl finally. So how many steps? I have gone through 4 steps, right? Since they have given not more than 4 steps, we can do this conversion in, right? So this is it. Right, okay. Then today also we learn a few reactions and we did some exercises related to these reactions, okay? So in the next week also, I'm planning to discuss a few more reactions and the exercises, of course. And likewise, this will be continued, okay? Until we discuss almost about 50 reactions are there. So until then, I'll do this session in this time every day, Sunday evening, 2:30 to 4:30 again. So if you have any doubts, you can ask me, okay? Personally send me a message and will help, right? So practice organic reactions. So it's not all about doing this thing only. You have to practice past paper questions also. You can try MCQs, essays, and even the structured essay question, the last part, everything you can practice that is related to the reactions. You have to remember organic. Organic is not easy, right? Because there are so many things to remember. That's why it's not easy. Okay. So, but if you do these things properly, it will be nothing for you. Okay. Okay. Then let's meet on the next week in the next session. Until then, bye bye. Have fun. Okay. Goodbye. Okay. Sorry. Bye.